Good evening, my friends, my second year PU friends. Good evening. Welcome to my channel Belagali's classes. Already we have started with the calculus, one of the very important chapter in PUC's second year syllabus. My friends, I told in the morning this calculus almost takes what? 1/3 of your question paper, or 1/3 of the syllabus, 1/3 of your question paper. If the question paper is of 100 marks, actually in calculus between 33, 34, 35 marks, my friends, 1/3. So important. In the first video, my friends, I covered almost all the basics, including what do you mean by calculus? Calculation of what? Quantities. What kind of the quantities? Constant quantities. Quantity which remains the same. It never changes its value. Constant. Then two types of the constants. Absolute constant, arbitrary constant, I told. Then comes another variable. What is variable? It is a quantity which changes its value. Yes, my friends. Variables are denoted by the letters X, Y, Z, U, V, W and T. Constants are denoted by the letters A, B, C, K. Normally C and K we used to take, my friends. Then in case of variables there are two types. One is a dependent variable, another is a independent variable. That I made it clear by taking the example area of a circle. What is the formula? A equal to pi r square. What is our radius of the circle? By giving values for r, I show explained what area of a circle is a function of its radius, written y equal to f of r. The same thing we have considered, my friends, two variables x and y. Two variables x and y connected. Two variables x and y are such that the value of y depends on x. Then y is defined. Y is called as what? Function of x, and is written symbolically as y equal to fx. This fx is a symbol, and we have to read this as what? Function of x. Function of x. My friend, this variable is independent variable, and this is dependent variable. Yes, my friends. After this, I told the types of functions. What they are? Algebraic functions, I told. Trigonometric functions, told. Exponential functions, logarithmic functions. These are the four. Along with these four, one more is there, my friends, that is hyperbolic functions. The syllabus doesn't allow to explain about what hyperbolic. It is not there, my friends. We have to go with four. Yes, my friends. After that, another very important is the meaning of x tends to a, my friends. X tends to a. I took particularly one number, x tends to 2. X tends to 2. My friends, this is number line, this is your number 2, X tends to 2 and x equal to 2. What do you mean by x equal to 2? Yes, ma'am. The exact value of x is 2. It is only one value. X equal to 2 means it is only one value. What is the exact value of x is 2. Then what do you mean by the meaning of what? X tends to 2. X tends to means approach. Approach means what? Coming closer. X comes closer to 2 in two ways. Taking x tends to 2 through left. In this case, x takes the values less than 2. I told in the morning, means the previous video, the values of x are what? 1.9, 1.99, like that told. This is one approach. X tends to 2 through left, takes the values less than 2. Another is what? And then this x tends to 2 through left, or values of x less than 2 we denote by the symbol x tends to 2 minus, or x tends to the same minus. Sometimes we write on the top, in front, any one, both are correct, both we use. Another one is what? X tends to 2 through right means what? From this side it comes, from this side it comes, from this side it comes. This is known as right of 2, this is known as left of 2. This side the values are less than 2, this side the values are greater than 2. X tends to 2 through right, or taking the values greater than 2, we denote symbolically as what? X tends to 2 plus, x tends to 2 plus. This is only one in this case what? When x tends to 2, the values of x are what? Infinite. 5, 1.9, 1.99, so many lines. This side 2.1, 2.01, 2.001, 2.0001. This side many values, this side many values. Tends to means in that case x will take what? Infinitely many values. Whereas x equal to 2 means unique value, only one value. My friends, note this difference. Tends to 2. Tends to, x takes the values very near to 2. Very near to 2. And x equal to 2 means exact value of x is 2. Yes, my friends. This I made clear in the morning. Means in the previous video. Yes, my friends. Yes, my friends. And the same thing I told this. Even x tends to 0. You mean x takes the values nearer to 0. Then it never takes 0. X tends to a. X never takes a, like this. Everything, my friends, explain. Yes, my friends. Next. See. Next comes limit and values of the function. Value and limit of a function. Value and the limit of a function. Say y equal to fx. Y equal to fx. In particular, you consider y equal to, my friends, it is 3x squared minus 5. 3x squared minus 5, or you can say, okay, y equal to instead of y, you can take function fx equal to this. Then find f of 2. Yes, my friends, f of 3, f of 1, like this. Tell what is f of 2? You have to put x equal to 2. X equal to 2. Yeah, it is 3 into 4 minus 5. 12 minus 5 means this is 7. This is 7. Yes, my friend. Like that. Even f of 1. What is f of 1? 3 into 1 minus 5. It is 3 minus 5. You mean it is minus 2. In this case, this 7 and 2 are known as, they are functional values. This 7 and 2 minus 2. 7 and minus 2 are known as functional values, or values of the function fx. Yes, my friends. Already about the limit, everything, that entire topic you have completed in PUC first year. I don't want to explain, give much time about what? Limit. Okay. Now you know the method of finding the limit. Yes. In this case, limit of fx as x tends to 2. Yes. What is it? Limit of fx is 3x squared minus 5 as x tends to 2. Again, what you are doing, you are putting x equal to 2. X equal to 2 in fx 5. So what is it? 4 into 3 is 12 minus 5. My friends, it is 7. What is this 7 and what is that 7? This 7 is known as the functional value. Functional value. And what about this 7? This 7 is known as limiting value of fx. Limiting value of fx. My friends, you know the difference between limiting value, functional value. As I explained here, still it is there. What do you mean by x equal to 2? Only one value, exact value, x equal to 2. X tends to 2. There exist what, my friends? About 2. In the neighborhood of 2, there exist infinitely many values. They are the values, they never take 2. Different from 2. Either less, otherwise slightly greater. Slightly greater, otherwise slightly less. But never be 2. This 2 is exact value. Tends to is limiting value. This is known as x tends to 2 means it is a limiting value of x. What is this? It is exact value of x. Exact value of x is 2. Limiting value of x is 2. Either less, otherwise bigger. Limiting values means there exist more values. On the same lines. What about this 7, my friends? Functional value. What do you mean by functional value? Exact value of fx is 7. This is the only one. Exact value of fx is 7. This is the only one. It is a unique value. It is unique. It is only one. Then what do you mean by limiting value? Limiting means it comes closer to 7. These are the values. This 7, it is not exact 7. What is it? It is 6.9, 6.99. Like this, man. Many values, all these, my friends. Or 7.1 or 7.01 or 7. So many zeros. 1. This is what in this case, even though it is 7, but it is not exactly 7. It is a value which is very near to 7, like this, my friends. There are so many values. This is a limiting value. This is functional value. Therefore, in finding the value of the function in the limit of the function, what the method says, directly we are putting the value of x. If you put x equal to exact functional, limiting value of x, x tends to limiting value of x, that is called as limiting value of the function. Yes, my friends, I made it clear. Then I take another example. Another example is what? Fx equal to x cube minus 8 or x square minus 4, anything, x minus 2. My friends, yes, x minus 2. Yes. Now functional value, put x equal to 2. Put x equal to 2 means what? Exact value of x. This is f of 2. Exact functional value. What is this? 2 to the power 3 minus 8 upon 2 minus 2. What is it? 8 minus 8. 8 minus 8 upon 2 minus 2. My friends, 8 minus 8. Down is what? 2 minus 2. 2 minus 2. Yes. What is the case? Functional value 0 by 0. What is it? It is not defined. What is it? It is undefined. 0 by 0 is undefined, meaningless. It is called as indeterminate forms. Everything, my friends, while doing the limits, done. Just I am reminding. Indeterminate forms. It is what? Undefined. Which is undefined. It is undefined. It is called as what? Indeterminate form. It is known as indeterminate form. Yes, my friend. Yes, my friend. In this case, what? Value of the function fails. Value of the function. Value of the function, my friends, fails. Value of the function fails. Value fails here. But what about the limit of this? Limit exists, my friends. Limit exists. See, if you take limit of fx, limit of fx as x tends to 2. What is this? It is limit as x tends to 2. What is fx? X cube minus 8. X cube minus 8 upon x minus 2. Yes, my friends. There is one mathematical technique. What is that? While doing the calculations, means during mathematical calculations, if this form 0 by 0, which is known as indeterminate form, exists, comes, in that case, we must what? Change the form of the function. Change the form of the function by using mathematical techniques such as using the factorization, otherwise using rationalization, or using what? Trigonometric formula or any algebraic formula. My friends, either using what? Factorization, rationalization, or use of any formula, algebraic or trigonometric, we must change the form. We must change the form of what? fx. Yes, my friends. In this case, we can change it. It is limit as x tends to 2. Yes. Factors x minus 2. What is it? X square. Change the sign plus 2x plus b square means 4. Down is x tends to 2. X. Down is x minus 2. Next question. Can you cancel x minus 2 with x minus 2 is a question. In this case, my friends, still it is there. What is the value of x? Not 2. What is the value of x? It is little more. The value of x is little more. It is what? 2.001. What is this in this case? The value of x is it is 1.99. If you take the difference, my friends, 1.99 minus 2, it is other than 0. What about this? This minus 2, other than 0. If it is 0, you can't cancel it. In that case, it is undefined as x tends to 2. Approach comes, my friends. X minus 2, both are not equal to 0. When x minus 2 is not equal to 0, you can cancel x minus 2 with x minus 2. You are left with limit as x tends to 2, x square plus 2x plus 4 plus 4. What is this, my friend? Tell. 2 square plus 2 into 2 plus 4. What is it? 12. From this, my friends, what is clear? Even though the value of the function fails, but limit of the function exists. Value fails, limit of the function exists. Therefore, my friends, when the value fails, in that case, at least limit of that respective function exists. This is one example. Otherwise, you can make use what? Direct formula. Which formula? X to the power n minus a to the power n upon x minus a, limit as x tends to a. You can use this direct. You can get the value as what? 12. Yes, my friends. So, through this example, what I wanted to tell, functional value, limiting value, they are different. Even though the function fails, limit of the function exists. In some of the examples, my friends, both limit as well as value of the function exist. Both limit as well as value of the function exist. Yes, my friends, I hope it is clear. Yes. Now, this is how the limit man, this chapter, when the value fails, mathematicians introduced limit of the function, and when value fails, the limit of the function exists, my friends. Yes, my friends. Then how to write limit of the function? This is a way of writing limit of fx as x tends to 2, or in general x tends to a, x tends to a. Yes, my friends. This is limit. What is this? This is value of the function. What is that value of the function? F of a. Value of the function is x equal to a. Yes, my friends. Next, my approach is here. X tends to 2 through left. Limit of the function as x tends to 2 through left. taking the values less than 2, such a limit is called left hand limit, my friends. Such a limit is called left hand limit. This here, this is left hand limit. Left hand limit. In this case, what it is? Limit of fx as x tends to, yes my friend, it takes what? Values less than 2. Values less than 2. Now what about in this case? This is what? It is limit of the function fx as x tends to 2 plus, and this is known as RHL, that is right hand limit. So limit of the function as x tends to 2 plus, if it exists, that limit is called as right hand limit of the function fx, denoted as what? RHL equal to limit of fx as x tends to 2 plus. What is this? Limit of fx as x tends to 2 minus means what? Left hand. Values of x less than 2, values of x greater than 2. This side is a right hand limit. This side is right hand limit, this side is left hand limit. What is this, my friend? Value of the function at x equal to 2. Value of the function at x equal to 2. Yes, my friends. LHL, value RHL. And the limit of the function exists. Limit of the function exists only when LHL equal to RHL. Only when LHL equal to RHL. If LHL is not equal to RHL, limit of the function as x tends to a does not exist. Does not exist. Yes, my friends. While doing the continuity of the function, we need value of the function LHL, RHL. Now I give what? Those three definitions. First, value of the function. Next, limit means what? Left hand limit of the function, right hand limit of the function. When the limit exists, if both LHL, RHL exist finitely and they must be equal, in that case the limit of the function exists. Just we will see what is value, what is limit, left hand limit. Yes, friends. My friend, I will mention the other indeterminate forms. Other indeterminate forms are infinite upon infinite. Another is infinite minus infinite. What about the fourth? Either it is 0 into infinite or infinite into 0. This is 4. Then 1 to the power infinite, infinite to the power 0, and 0 to the power 0. 1, 2, 3, 4, 5, 6, 7. These are 7 indeterminate forms. 7 indeterminate forms. Infinite upon infinite, infinite minus infinite, any one, either 0 into or infinite into 0. 1 to the power infinite, infinite to the power 0, 0 to the power 0. These are 7 indeterminate forms. Indeterminate forms. Now I will come to the value of the function. Definition. Value of the function fx at x equal to a means at the point x equal to a is obtained putting means putting x equal to a in fx and is written or denoted, anything you write, written as f of a. What we have done in fx we have substituted x equal to a. If you put x equal to a, then it becomes what? F of a. Therefore, what is f of a? f of a is value of the function fx, value of the function fx at x equal to a, Remember my friends, we want it. This is one. Next is left hand limit. This is left hand limit. Next is left hand limit. Yes, my friends. Left hand limit. We write in brief LHL. Yes, my friends. If the limit of fx, fx as x tends to a through left, I write it in the bracket. That is, values of x are less than a if limit of fx as x tends to a through left means values of x less than a exist. It is understood finitely and uniquely. Exist finitely and uniquely, then this limit is called left hand limit of fx. Therefore, my friend, what is LHL? LHL is limit of fx as x tends to a minus. This minus you write either front, otherwise on the top of a, either here or here. Anything I write here. LHL is this. Similarly, tell my friends, what is RHL? Similarly, RHL is what is it? RHL is limit of fx as x tends to a plus. A plus means what? In that case, that x tends to a through right, values of x greater than a. Therefore, this is right hand limit, my friends. Yes, right hand limit. Yes, if limit of fx as x tends to a through right, then if limit of fx as x tends to a through right exist finitely and uniquely, that is understood. Why? If at all the limit exists, always it is unique and finite. Okay, exists finitely and uniquely, then this limit is called, I have to mention, my friends, through right means that is values of x greater than a, you must know, greater than a. Through right means that is values of x which are greater than a exist, then this limit is called right hand limit of fx. Yes, my friends. Therefore, what is RHL? RHL is limit of fx as x tends to a plus, my friends, a plus. If it exists, it is RHL. Then what is the note, my friends? Note. If LHL equal to RHL, if LHL equal to RHL, then limit of fx as x tends to a, limit of fx as x tends to a exists. Limit of fx as x tends to a exist. Otherwise the limit does not exist. Otherwise, limit of fx as x tends to a does not exist. Does not exist. Yes, friends. What it tells, note, if the left hand limit of a function is equal to right hand limit of a function, what is it? Limit of fx as x tends to a minus equals limit of fx as x tends to a plus. Then limit of fx as x tends to a, either plus or minus, this limit exists. Otherwise means what? If LHL is not equal to RHL, limit does not exist. If any one among the two, either this or that, if any one among the two does not exist, in that case the limit does not exist. Yes, my friends, this is how the limit of the function exists, and this is value of the function. By making use of this man, I write one more note is how to find LHL and RHL. In finding LHL, replace x by a minus h and take the limit as h tends to 0. And in finding RHL, replace x by a plus h and take the limit as h tends to 0. That also I write it as what? Another note. Yes, my friends. I write here down. In finding LHL of fx at x equal to a, replace x by a minus h and take the limit as h tends to 0. Therefore, tell my friend, what is LHL? Yes. Limit of fx as x tends to a minus, my friend. In this you have to replace what? Replace x by a minus h here, man. This is important. Where? In fx. Then take the limit as h tends to 0. Yes. This is what? In fx, replace x by a minus h and take the limit as h tends to 0. What is this? LHL. Similarly, I don't want to write in detail. In finding RHL, replace x by a plus h in fx and take the limit as what? H tends to 0. Therefore, what is RHL? Yes, RHL is what? Limit as fx as x tends to a plus equal to limit of f of a plus h as h tends to 0. This I write here. Similarly, same. What is it? In finding RHL, replace x by a plus h and take the limit as h tends to 0. No need to write all these in wordings. Same. In finding RHL, replace x by a plus h. In finding LHL, replace x by a minus h. What is that? A point, my friends. It is a point. If the point is 2, 2 minus h, h tends to 0. If the point is minus 1 minus h, h tends to 0. Always you must replace, my friends, x by the respective point. If it is a 2, 2, 1, 1, 5, 5. Minus h is LHL, plus h is RHL. Finally, you have to take what? Limit as h tends to 0. This is the method of finding what, my friends? LHL and RHL. This plays a very important role in case of what? Continuity of a function. Continuity of a function. Yes, my friends. So this is about LHL, RHL, and what? And what? Limit of a function. Limit of a function. This is value of the function. F A. Yes, my friends. Yes, from this is for what? Value. This is for what? LHL. This is for what? RHL, my friends. RHL. The value is greater than the point, RHL. The value is less than the point is what? LHL. The value where exact is value of the function. Remember. Yes, my friends, x tends to a through left. Values of x less than a. In this case, it is what? A minus. This is for LHL. Left hand limit. This is for LHL. What is this? X equal to a. This point. X equal to a. This is for the value of the function. X tends to a plus, my friend, means what? Value is greater than a. Right. This is for what? RHL. Yes, my friends, I keep okay, for one or two examples. That's all. I keep it. This is value means f of a. Value means f of a. RHL means limit of fx as x tends to a plus. LHL means limit of fx as x tends to a minus. This is for LHL, this is for value, that is for RHL. Three divisions. Yes, my friend. This is about LHL, RHL, and value of the function. Now I give some properties of limits. Theorems, you can say properties or theorems we have done. Introduce first here. Theorems in limits. Properties or theorems. Yes, my friend, you know it. This is limit of fx plus or minus gx. Fx plus or minus gx. Equal to as x tends to a equal to. This is limit of fx as x tends to a plus minus limit of gx as x tends to a. Means limit of sum is sum of the limits. Limit of what? Difference is difference of the limits. Second one, limit as x tends to a, this is my friends product fx into gx product. Yes, this is limit as x tends to a, it is what? Fx into limit of gx as x tends to a. My friends, product is product. Then division is division. Limit as x tends to a, it is fx upon gx. It is limit of fx as x tends to a. Down is limit of gx as x tends to a, provided g of a should not be 0. G of a should not be 0. And this one, limit of k into fx. What is that k? Constant. K into fx as x tends to a is what? K times limit of fx. Limit of fx as x tends to a. Like that, mod function. Even this one we use, what is it? Limit of log of a function, log fx is same as what? Limit of log of limit. Limit of log, my friend. Limit of log of fx as x tends to a, this is log fx is same as log of fx, log of fx, log of limit of fx, limit of fx as the x tends to a. This is very rare use, These are very useful. What is it? Limit of sum is sum, difference is difference, product is product, division is division. Any constant which is a coefficient, that constant coefficient remains outside the limit of sign k into limit of fx. And one more is this, my friends. What is this? Limit of any constant as x tends to a is that constant itself. So limit of 5 itself, limit of 10 itself, limit of minus 10 itself. Yes, my friends, these are some properties. Along with this, man, we have done last year these properties, these theorems. This is an algebraic function. X to the power n minus a to the power n upon x minus a. Yes, my friends, it is n into a to the power n minus 1. Next one, it is limit as theta tends to 0. It is a trigonometric function. Sin theta by theta is 1, which is same as even for tan. Even for tan theta. Tan theta upon theta is 1. Not necessarily sin theta by theta. Even it is theta by sin theta. Theta by tan theta. Even in this case, as theta tends to 0, the limit is 1. This is on exponential functions, my friends. Limit as x tends to 0. E to the power x minus 1 upon x. See, what is here? Power must be same as denominator as x tends to 0. It is also 1. If the power base is other than e, a minus 1 upon x equal to log a to the base e. Yes, my friend. Yes, these are the basic. These are done what last year proved. First PUC, algebraic, trigonometric, exponential functions. Yes, my friends. Along with this, one more thing that I want to just mention and explain is about the intervals. Yes, my friends. Let a and b are two numbers such that a is less than b. A and b are two real numbers such that A is less than B. Yes, my friend. Now, your friend X, if he takes only between values, except A and B, that is called as open interval. Open interval. What is open interval? Symbol. Usual bracket. Open interval. Usual bracket. What is this, my friends? It is a set containing X such that A is strictly less than X, strictly less than B. In this case, my friends, X will take the values, all values between A and B except A and B. It never takes what? A and B. Even you can write them by what? Open circle. Open circle means X will not take these ends. It will take what? All these values. In that case, it is said to be open interval. Next, if it takes both the ends, this is open. If it takes what? Both the ends like this, my friends. Both the ends. Yes, it will take this end as well as this end. In this case, my friends, between as well as ends, it is known as closed interval. Closed interval. What is the symbol? A rectangular bracket. In this case, what is this? It is a set containing X such that both man included means what? Equality comes. What is another one? Semi-closed, semi-open. In this case, my friends, it is closed. It takes this end but not this end. In this case, it is called as what? Semi-closed. Semi-closed. Semi-open in this case. Semi-open. What is this? It is a set containing X such that closed means equality, open means less than. What is another one? This, my friend. This is closed. This is closed. This is open. What is it? It is open interval A, semi-closed B. Yes, in this case, it is a set containing X such that A less than X but less or equal to B. This is semi-open, semi-closed, semi-closed, semi-open. It is closed interval. This is open interval. These are the definitions of what, my friends? Intervals. I made it clear before starting that continuity part. These are known as intervals. These are the theorems done. Just we have mentioned this. We have proved this. Yes, my friends. This is about what? Intervals. Finally, we come to what to mean by continuity of a function. This is about the limit, value, everything. What is it? It is value of the function at x equal to a, f of a. This is limit of fx as x tends to a. This is through left hand limit. Through right, value is greater, right hand limit. If LHL equal to RHL, limit of fx as x tends to a exists, my friends. Yes. Now I will come to continuity of the function. Okay. That definition I give. I hope all these basics are clear. Every basic is made clear. Intervals, value, limit, LHL, RHL. These three plays very, very important role in doing the examples on continuity, my friends. So it is made clear. Yes, my friends. Next comes continuity of a function. Yes, friends. Continuity. continuity of a function. Yes, friends. Definition. Continuity of a function at a point x equal to a. X equal to a. Yes, I write the definition. A function fx is said to be. A function fx is said to be. Fx is said to be continuous. Is said to be continuous. Continuous at a point x equal to a if limit of fx as x tends to a and f of a value exist finitely and what, my friends? Limit of fx as x tends to a equal to f of a. Yes. A function fx is said to be continuous, my friends, at a point it is at a point. See here. This is at a point x equal to a finitely, and what? That limit must be equal to value of the function. If the limit of the function equals value of the function, then we say the function is continuous at the point x equal to a. Otherwise means what? Any one among the two doesn't exist, or exist but not equal. In that case, the function is said to be not continuous or discontinuous at the point x equal to a. But we know what is that node. What is that node? Limit of fx as x tends to a exist only when both LHL RHL must exist. Both LHL and RHL must exist. Finite is there, must exist, and they must be equal. LHL equal to RHL. They must exist finitely, and they must be equal. Therefore, limit of fx as x tends to a exists only when both LHL RHL must exist finitely and they must be equal. Otherwise, the limit does not exist. Therefore, we can extend the definition. Of what? Continuity in another way. What is that? Therefore, from this it is clear. Fx is said to be continuous. Fx is said to be continuous at the point x equal to a. If all the three if value f of a, LHL, RHL, all the three must exist finitely. And they must be equal. And value of the function f of a equal to left hand limit of the function equal to right hand limit of the function. That is what is value of the function f of a? What is left hand limit? Limit of fx as x tends to a minus. What is RHL? Limit of fx as x tends to my friends, a plus. Yes. So the function is said to be continuous at a point. Function is said to be continuous at a point only when all the three must exist and they must be equal. They must be equal. Otherwise, any one among the three doesn't exist. Both LHL or RHL exist, they are not equal. Even any one among is not equal. In that case, the function is said to be discontinuous. Otherwise means any one fails, doesn't exist, or all the three exist, any two are not equal, like that. Otherwise, the function is discontinuous. The function f(x) is discontinuous. Discontinuous or not continuous. Not continuous at that point. At that point, my friends. And graphically, you know the graph of mod function. Graph of mod x. Fx equal to mod x. We have done what last year? Modulus function, even greatest integer function. Like that, man, we have done some what? It is origin x dash y dash modulus function. See, my friend, what is this? It is a continuous curve. Line without break. Line without break means what? No gap is there. When the no gap is there, in that case what? It is a continuous graph. Continuous graph means what? This mod x is a continuous function. Mod x is a continuous function. Now if you want another graph, that another graph is, it is a graph of function fx equal to graph of fx equal to, my friends, it is x square minus 4 upon x minus 2. In this case, value fails at x equal to 2. Value fails at x equal to 2. Then what is the graph in this case, my friends? It is also a line like this. Line like this. But somewhere at x equal to 2, the break comes there. At x equal to 2, that break comes here. It is x equal to 2, the break comes here, my friend. Again, it is like this. It is not a continuous line. In that case, we say that this function is a discontinuous function. Why? Its value does not exist at x equal to 2. Value fails to exist at what? X equal to 2. In this case, it is a graph of a function which is discontinuous. At x equal to 2, some gap is there. Here. So this is a continuous function, graph of. Another is continuity of a function in the interval. Last one, continuity of a function in the interval. Continuity of a function fx in the interval. You can say I or closed interval, anything in the interval I. Yes, in the interval I. Yes, ma'am. A function fx is said to be continuous. A function fx is said to be continuous. In an interval I. If it is continuous, continuous at each and every point of the interval, at each and every point, every point of the interval, my friends, this is the interval. This is continuity at a point. This is one point x equal to a. In the interval means what, my friends? At each and every point, if the function is continuous, then we say function is what? Continuous in the interval I. Continuous in the interval I. Yes, my friends. Now we just reached up to what? Continuity. We have completed what we mean by limit, value of the function. Everything explained, my friends, which are very important as a basic. Yes, my friends. What next? Next is examples of continuity. These examples you have 4 mark example. One example under 4 mark. 4 mark already you know it. Where it comes? Part E for the board exam. Part E for the board exam. Yes, my friends. Today this much is enough up to this continuity, and next I will continue with examples on continuity. Yes, my friends. Thank you very much. Yes.